Welcome guys, we are back with another Leetcode problem. Today is day 30 of Leetcode. Let's see the question. Today's question is medium, is a highly liked question, and the problem is minimum number of arrow to be needed to burst the balloons. So there are some spherical balloons tapped onto the flat wall and that represent the XY plane. So there's a plane XY plane, let's assume, and we are just tapping the balloon onto the wall, and the balloon are represented as 2D integer array. Okay, point x start and x end denote a balloon whose horizontal diameter stretches between the x start and x end, and you don't know exact y coordinate the balloons. Arrow can be shoot directly vertically, okay, from the different point along the x direction, and a balloon x started and x end is burst by the arrow shot at x. Okay, if x start is uh, less than equal to x, less than equal to x end, so there is no limit the number of arrow that can be shot. A short arrow keeps traveling up infinitely, bursting any balloon in this part. Okay, so given the arrow point, return the minimum number of arrow that must be shot to the balloon, all the balloons. Okay, so let me explain the question. What question actually asks? You have given a plane, and in this plane you just there is a uh, balloons are stick with that, and you have to you have given an arrow, and you need to minimize the number of arrow needed to be burst the all the balloons. So what the maximum possibility to burst the balloon? uh, if let's take the example one. If you want to burst the balloon, all the balloons, so 1 2 3 4, you needed at least four. uh, you have a max. If you want to burst the balloon, you maximum use four four arrowhead to burst the four balloons. But could you do could you do better than? Yes. So what we are going to do, if we want to burst the balloon with using a lesser number of the arrows, what we are doing, we are just uh, throw the arrow on such a coordinate where these balloons are collapse, means overlap to each other. So if I have two balloons, one is here, one is here. If I move, if I rotate here, so this is a point where it bursts the both balloon if I throw on that coordinate. So we have to find the such an coordinate where maximum overlap is present, and if we throw the arrow on that coordinate, it bursts the balloons. Okay, so it's a little bit overlapping problem. I'll just try to find out the all overlapping thing. Here you can say 2 8 and 1 6, both are overlapping at the position of 6. Could you get this thing? Both are overlapping at the position of 6, and here shoot the arrow at 11 x11, so it's bursting the balloon 10 and 7 12. So it's kind of tricky, but if you go, yes, these two balloons are can be burst at the position of 6. If I throw the arrow on the at the coordinate of 6, it bursts this and this balloon both. If I throw the arrow at the position of 12, it can burst this and this. So what I notice one thing, if I sort my array, if I sort this array on an increasing order, what I do on the position of this last index, it kinda easy to find out uh, where put the arrow through the arrow, it can burst maximum. So in that case, when I sort this array, let's pick here and put here. So when I when I sort this array on the basis of my second element index, so it can be like this. So first it write it 1 6, after that 2 8, after that 7 12, after that 10 16. So how many arrow we have to need it? If I just uh, throwing my arrow at position of 6 coordinate 6, it can burst this balloon, it can burst this balloon too, because 6 is overlapping between it. So it can burst this too, but it can't burst this. So here I use another arrow which having this, which I throw on the position of 12. It, and this arrow can burst this as well as this, uh, because 12 is lying between 10 or 16, so it can burst this. So this is my basic optimum solution. I have to sort the array into the basis of my second index, and after that I'll just make my arrow, I just throw the arrow on that position and just burst the balloon until it overlapping. If it not overlapping, I'll just choose the second index and then I comparing it, and then I again bursting the balloons. So that's my basic intuition. Let's code it, guys, and uh, by the using writing the code you can understand better. So what I do, I just sort the array. So it's a point, I'll just make it p for make some sense and easy to write. So it's begin and p dot end. But here I use my own comparator. Here I use my own sorting technique. I have to sorting on the basis of the second index. So what I do, I'll make my own comparator which going to sort this array on the basis of second index, and after that it can be look like this. Let's make my comparator after some time. Let's try to fill this code. Let assume my comparator make this sort function make my uh, vector like this as my required. So what I do, I have to need one arrow and make a result in which I show going to return my answer. Let's make its answer for makes more sense. And I am assuming I need only one arrow which at position of p0 p1. I just pick this element and I want to bursting the balloon one by one. If it's bursting, it's okay. If it's not bursting, I enhancing my answer, because one arrow is not sufficient for bursting all balloons, so I have to enhance the arrow. So that's the thing. But first and foremost, I have think this first first arrow point can burst all the balloons. Okay, so I make my follow. I have traverse everything. So it's a and period size and I plus plus. So if I know one thing, if my this arrow is greater, if my arrow p is greater than this one initial one, it means it burst, because it's also sorting. So it means lesser have the lesser can be present here, or maybe equal may be present. It can be 6 6, So that's why I added 6 to equal to equality to. So it's kinda comparing with the first index of that. Sorry, it's a first index of that. Means I'm only comparing with this. If this one is greater, lesser than my arrow or equal arrow, yes, then I'll just continue because it can possible to burst this balloon. If my arrow is pointing here, it can be burst this balloon. If my 6 is here and 2 is smaller than, it means it's like it overlapping between 6 is overlapping between this range, so it means it's also burst this balloon. But here 7 is greater than my 6, it means I can't able to burst the balloon. So it means I have to enhance my arrow number, as well as I have to pointing my arrow now, it's pi of one position. That's it. And after that, what I have to do is enhancing my number of arrows as well. And after that, what I do, I just return my answer. But before returning, let's make our comparator function too. So for making the comparator has a boolean type, and it's take the two parameter for the comparison purpose. Here here is the two parameter is, here I take the vector form because it's a 2D vector. So this thing, if I want to compare this and this, I have to take in vectors. So I make two vectors, vector vector v1 and vector v2, vector v2. And now what I do, I have to comparing if my v1 is greater than my v1 is greater than my v2 one, just return it. I'll just here I'll write 1 because I want to sorting with by using the first second index, so that's why I just do that. So let's run this code. And yeah, that's accepted. Let's submit our code. That's guys, that is accepted. So if you have any comment, let me know in the comment section. I'll be resolve your doubt as soon as possible. And take care, goodbye, and keep grinding.